Tonight, as the world slowly sinks into silence, allow your mind to slow down, as if we are stepping together into a journey far back in time. Welcome to Stories for Sleep, a quiet place where stories about history, science, and the human mind are told gently so you can explore the world while relaxing before drifting into sleep. In tonight's episode, we will travel back about 74000 years to a moment when Earth experienced one of the most powerful natural disasters ever known, a massive eruption from the supervolcano at Lake Tote. Some scientists even suggest that at that time, only around 2000 humans survived on the entire planet, the distant ancestors of every person alive today. If you enjoy calm historical stories told in a slow and relaxing way, remember to subscribe and turn on notifications so you won't miss future journeys with Stories for Sleep. And now, take a slow breath, relax your body, and let us begin tonight's story. When night falls and the world becomes quiet, we often imagine human history as a long and stable story, as if millions of people have always existed on this planet. But what many people don't realize is this: there may have been a time in the distant past when the entire future of humanity hung by a fragile thread. Imagine the world 74000 years ago. There were no cities, no written language, no electric lights, only small groups of humans scattered across the grasslands and coastlines of Africa. And then, in a place very far away on an island that today belongs to Indonesia, the ground deep beneath the earth began to tremble. A massive supervolcano was awakening. The eruption of Lake Toba released enormous clouds of ash into the atmosphere, enough to darken the skies of the entire planet. Sunlight faded, temperatures dropped, ecosystems shifted. And according to one controversial scientific theory, humanity may have been pushed close to extinction, with the global population shrinking to only a few thousand individuals. If that theory is correct, then nearly every human alive today may be descended from that small group of survivors. But this story is not only about a volcano, it is also a story about us. The famous psychologist Carl Gustav Jung once suggested that deep within the human mind lies something he called the collective unconscious, a place where ancient memories of humanity are preserved. Our instinctive fears of darkness, of natural disasters, of the fragile nature of life may not only be personal emotions, they might be echoes of distant moments when humanity truly stood on the edge of disappearing. Tonight, as you listen to this story, we will travel back in time to a wild and ancient Earth where ash fell like snow and the sky slowly darkened. We will explore one of the largest volcanic eruptions in millions of years, the genetic mysteries hidden inside human DNA, and a haunting question: did our ancestors truly survive an ancient apocalypse? Close your eyes gently, take a slow breath, and step into this journey through history like a deep dream of humanity. The sky darkens. Imagine a morning long ago in the distant past, not centuries ago, not thousands of years ago, but 74000 years ago. At that time, the world had no cities, no roads, none of the signs of civilization that we recognize today. Earth was still a wild planet, where vast grasslands stretched to the horizon. Ancient forests whispered in the wind, and humans were only one small species learning how to survive in a powerful natural world. In what we now call East Africa, a group of early humans woke as the first light of morning touched the grasslands. They did not know they were living at a remarkable moment in human history. They simply followed the rhythms of daily life, rekindling embers from the night before, checking their simple stone tools, preparing for a long day of searching for food. None of them knew that on the other side of the planet, deep beneath Earth's crust, something enormous was preparing to happen. Nature often sends quiet signals before great change arrives, and on that morning, the sky began to look different. At first, it was only a faint sensation, The sunlight seemed weaker than usual, as if a thin veil had formed across the atmosphere. They had no words to describe it, but deep in their instincts, ancient humans may have sensed that something was changing. Animals often notice these changes first. On the grasslands, herds of antelopes suddenly became restless. They gathered in tighter groups, their ears turning constantly, as if listening for a distant sound humans could not yet hear. Birds flew lower across the sky. Some species even abandoned territories they had lived in for generations. Elephants, creatures with the longest memories of the land, seemed to sense instability deep within the earth. They began moving slowly but deliberately, as if searching for safer ground. The humans watched in silence. In that ancient world, nature itself was a language. Small changes in animal behavior, shifts in the wind, subtle changes in the color of the sky, all carried meaning. And when many of those signals appeared at once, it often meant something powerful was approaching. But no one could imagine the scale of what was coming. Because far to the east, on an island we now call Sumatra, a supervolcano was entering its moment of eruption. It was the explosion of Lake Toba, one of the largest volcanic eruptions the planet had experienced in millions of years. Yet for the small human groups living in East Africa, all they knew was this: the sky was slowly darkening, and ash was beginning to fall like snow. Tiny particles drifted through the air, turning slowly, before touching the ground. In the faint sunlight, they shimmered like gray snowflakes, volcanic ash. But the ancient humans did not know that. To them, it may have seemed as if the sky itself was falling. Ash settled in their hair. It covered the ground, bushes, and small streams. Soon, a thin layer formed beneath their feet, leaving clear footprints with every step. The air began to change. It became drier, and it carried a strange smell, something like heated stone after rain. Animals grew more agitated. A herd of antelope suddenly sprinted across the plains, raising clouds of dust behind them. Monkeys cried out in long warning calls from the trees. The world seemed to be losing its familiar balance. According to Jung, deep within the human mind exists something he described as primitive shadow, ancient fears that exist beneath conscious thought. The fear of darkness, the fear of a changing sky, the fear of nature suddenly becoming unfamiliar. Perhaps these feelings first took shape in moments like this. Moments when humans realized they were not the center of the world, that enormous forces moved beneath the ground they walked on every day, that the story of humanity could be changed by a single geological moment. Ash continued to fall. The sky grew grayer, and deep within the earth, the planet released a colossal breath, one that might alter the destiny of our species. And yet, this story is only beginning. The Toba catastrophe hypothesis. When the ash from the massive eruption of Lake Toba spread through Earth's atmosphere, a large question began to form in the minds of modern scientists. What happened to humanity after that disaster? Today, when geologists, anthropologists, and geneticists examine the traces preserved in ancient ash layers and within human DNA, they have come to realize that this eruption may have marked one of the most difficult periods in the history of our species. From these investigations, an idea gradually emerged, a theory known as the Toba catastrophe hypothesis. According to this hypothesis, the eruption was not merely a geological event. It may have triggered a chain of global climate changes, severe enough to push humanity toward the edge of extinction. Imagine the Earth at that time. Thousands of cubic kilometers of ash and sulfur gases were thrown high into the stratosphere, where tiny particles could remain suspended for many years. As these particles spread through the atmosphere, they began reflecting sunlight back into space. Less sunlight reached the Earth's surface, and when sunlight decreases, temperatures begin to fall. Scientists call this phenomenon a volcanic winter, a period when ash and atmospheric gases cause the global climate to become colder than usual. In the most extreme version of the Toba hypothesis, average global temperatures may have dropped significantly for several years. Some studies once suggested that temperatures in certain regions could have fallen by several degrees Celsius, a change that might sound small but one capable of disrupting entire ecosystems. Plants grow more slowly. Animals struggle to find food. Food chains begin to tremble. When ecosystems shift, every living creature is affected, including humans. At that time, our species was still a very small presence on the planet. There was no agriculture, no stored food, no technology capable of controlling the environment. Humans depended entirely on nature. If the climate changed for years, survival could become extremely difficult. Because of this, some scientists proposed a startling possibility. The global population of Homo sapiens may have dropped to as few as 2,000 individuals. 2,000 people. If that number were accurate, then the billions of humans living today might all descend from a very small group that survived that harsh period. In genetics, this phenomenon is called a genetic bottleneck. Imagine a wide river flowing through a narrow canyon. When the river is forced through that narrow gap, only a small portion of the original flow passes through. In evolution, something similar can happen. When a catastrophe drastically reduces a population, only a small number of individuals survive. All future generations then descend from that small group. As a result, the species' genetic diversity becomes reduced. Interestingly, when scientists study the DNA of modern humans, they find that human genetic diversity is relatively low compared to many other primates. This observation has led some researchers to suspect that humanity experienced one or more significant genetic bottlenecks in the past. And for a long time, the eruption of Toba seemed like a strong candidate for such an event. If this theory is correct, then at some point in our history, the entire future of humanity may have depended on the survival of just a few thousand individuals. Small groups scattered across distant landscapes, communities that managed to keep their fires burning, continue hunting and find water and food in a world that was growing colder and less predictable. Those people had no idea they carried the future of humanity. They were simply doing what our ancestors had always done, surviving one day at a time. From the perspective of Carl Gustav Jung, collective experiences of this scale may leave deep marks within the human psyche. Jung believed that beneath individual consciousness lies a collective unconscious, a deeper layer of the mind containing symbolic memories shared by all humanity. Great natural disasters, harsh periods of survival, and moments when humans faced the fragility of life may become powerful psychological symbols. Perhaps that is why many cultures around the world contain ancient stories about dark ages, long winters, or times when humanity nearly disappeared. Though these stories differ in detail, they often share a similar message. Life on Earth has never been completely stable. Sometimes nature tests the resilience of living creatures, and sometimes it is during those trials that humanity's most important qualities emerge: cooperation, creativity, and the ability to hope, even in difficult times. In this sense, the Toba catastrophe hypothesis is not only a story about volcanoes or climate, it is also a story about the fragility of humanity, and at the same time about our resilience. Because even if the world passed through a harsh and cold period, humans continued to exist. Small groups kept moving across vast landscapes. They kept fires burning through the night. They continued telling stories beneath the stars. And tens of thousands of years later, their descendants, us, are still here, still able to look back at the past and ask, did our ancestors truly survive a long winter of humanity? Perhaps the answer still lies somewhere in ancient layers of ash and within the DNA of every person alive today. The world before the catastrophe, before ash from the eruption of Lake Toba spread across Earth's skies, our planet looked quite different from the world we know today. If we could travel back 74000 years and stand upon a high hill overlooking the horizon, we would see a world both familiar and strangely different. At that time, Earth was in the midst of an ice age, a long climatic period when global temperatures were lower than they are today. Massive glaciers covered the polar regions and extended far across parts of the northern hemisphere. These enormous ice sheets, sometimes kilometers thick, were so heavy that they reshaped the continents themselves. In distant northern lands, glaciers stretched across valleys like shining mirrors reflecting sunlight. Yet in many other parts of the world, especially in Africa, life remained vibrant. Savannas stretched across the land. Open forests swayed in the wind. Ancient rivers carved their paths across the landscape. Another major difference from today involved sea levels. Because so much water was locked inside polar ice sheets, global sea levels were about 80 meters lower than they are now. This exposed vast areas of land that today lie beneath the oceans. These lands formed natural bridges between continents. In Southeast Asia, many islands that today are separated by sea were once connected by wide plains and forests. Animals and humans could travel between them across natural corridors. In other parts of the world, newly exposed coastal plains created enormous feeding grounds for wildlife. In a way, the world itself was larger. Many pathways between regions existed that today have disappeared beneath the sea. And across this immense world, humans were still a very modest presence. The species Homo sapiens lived mostly in Africa, the ancient cradle of humanity. They lived in small groups, often only a few dozen individuals. These groups moved with the seasons, following water sources and migrating animals. They built no cities. They practiced no agriculture. They had no concept of nations or borders. Their world was defined by rivers, hills, and familiar hunting grounds. The total population of humans was very small compared with today. Perhaps only tens of thousands of people existed across the entire planet. Seen from above, Earth would have appeared almost entirely wild. Herds of animals moved across grasslands. Ancient forests whispered in the wind. And humans with simple stone tools and small fires were only a tiny part of this living landscape. But there was another fascinating difference in the world of 74000 years ago. Modern humans were not the only human species alive. Many human species shared the world today. When we say human, we usually mean our species, Homo sapiens. But for much of evolutionary history, our species was not alone. In fact, the ancient world was like a vast evolutionary forest, where several branches of the human family tree existed at the same time. If we could travel back and observe the planet, then we would see different human species living separate lives across different regions. In Africa, the direct ancestors of modern humans, Homo sapiens, lived in small communities along savannas and rivers. They made stone tools, used fire, and were developing increasingly complex forms of communication. But far beyond Africa, other human relatives existed. In Europe and parts of Western Asia lived the Neanderthals. Neanderthals were shorter but more muscular than modern humans, with thick bones and powerful bodies adapted to survive in the cold climate of Ice Age Europe. They hunted large animals such as bison, deer, and sometimes even mammoths. They used fire, crafted sophisticated tools, and may have cared for injured members of their communities. For a long time, Neanderthals were portrayed as primitive, but recent archaeological discoveries suggest they may have been far more complex, possibly burying their dead, decorating their bodies, and even creating simple forms of art. Farther east across the mountains and plateaus of Asia, another mysterious group existed. Scientists call them the Denisovans. Interestingly, Denisovans were discovered only recently. Most of what we know about them comes not from complete fossils, but from small bone fragments and ancient DNA. Yet genetic evidence suggests that Denisovans once lived across vast regions of Asia, from cold Siberia to areas near Southeast Asia. And then on a remote Indonesian island, scientists discovered something truly surprising. A small human species called Homo floresiensis, often nicknamed the Hobbits. These humans stood only about 1 meter tall, Their brains were smaller than those of modern humans, yet they still created stone tools and hunted animals on their island home. Their existence reveals that human evolution was not a straight path. It was more like a great tree with many branches, each adapting differently to its environment. So when we imagine the ancient world, we might picture a planet where several kinds of humans walked the earth. Homo sapiens on African savannas, Neanderthals in the cold valleys of Europe, Denisovans across Asian highlands, and the tiny Homo floresiensis on a distant island. Each carried its own evolutionary story. Each represented a different possibility for humanity. According to Jung's perspective, recognizing that we are only one branch of the human evolutionary tree can create a deep sense of humility. Jung believed humans carry layers of ancient psychological memory patterns formed through hundreds of thousands of years of evolution. Perhaps some of those memories originated during this era, when multiple human species shared the world, a time when humanity had many possible futures, yet over time the other branches gradually disappeared. Neanderthals vanished about 4,000 years ago. Denisovans faded from the fossil record. Homo floresiensis also disappeared. Only one branch remained, Homo sapiens, us. And that realization makes human history both extraordinary and fragile. Because our survival was not inevitable. If events had unfolded slightly differently, perhaps another human species would be the only one left today. But somehow our ancestors endured. And when the eruption of Lake Toba occurred, all these human species, though living in different lands, shared the same ancient sky, a sky that would soon be darkened by one of the greatest natural disasters in Earth's recent history, the formation of a supervolcano. When we look at a volcano, we usually see a quiet mountain. Sometimes it is covered with forests. Sometimes it rests peacefully beneath the sky like any other mountain. But deep beneath that calm surface, our planet is anything but still. Earth is a world that moves slowly, where enormous forces are constantly at work beneath the ground. These movements do not happen over days or years. They unfold over hundreds of thousands, even millions of years. The story of the ancient supervolcano beneath Lake Toba begins with those slow movements. Beneath the continents and oceans of Earth lie enormous slabs of rock called tectonic plates. These plates drift slowly across a softer, hotter layer of rock deep below the surface. They move incredibly slowly, only a few centimeters each year. But over geological time, even such tiny movements can reshape the entire planet. In the region we now know as Indonesia, a remarkable process has been unfolding. There, the Indo-Australian tectonic plate slowly slides beneath the Sunda plate. This process is called subduction, one of the most powerful mechanisms in geology. Imagine two enormous carpets slowly sliding over one another. As one carpet is pushed underneath the other, it gradually sinks deeper into the hot mantle of the Earth. As the rocks of the Indo-Australian plate descend into the mantle, they carry with them water and minerals trapped in the rock over millions of years. At great depths, temperature and pressure increase dramatically. The water and minerals begin interacting with the hot mantle below. This interaction lowers the melting point of the surrounding rock, and as a result, some of that rock begins to melt into magma molten rock at extremely high temperatures. Because magma is lighter than the solid rock around it, it slowly begins to rise through cracks in the Earth's crust. In many places on Earth, this magma creates ordinary volcanoes. But sometimes, when geological conditions are just right, the magma does not immediately escape. Instead, it accumulates in enormous chambers deep underground. That is exactly what happened beneath the region of Toba. Over hundreds of thousands of years, magma continued to gather inside vast underground chambers. Each new pulse of magma increased the pressure within that system. Imagine a gigantic pot slowly heating from below. At first, everything appears calm, but as the temperature rises, the pressure inside the pot begins to increase. Eventually, the system can no longer contain that pressure, and when that moment arrives, the stored energy is released with extraordinary force. In the case of Toba, the pressure that had built up for hundreds of thousands of years finally shattered the crust above the magma chamber. The result was an eruption that scientists today classify as VEI-8, the highest level on the volcanic explosivity index. An eruption of that magnitude is very different from ordinary volcanic events. It does not simply send lava flowing down the slopes of a mountain. Instead, it destroys the entire structure of the volcano. Large sections of Earth's crust collapse inward, creating massive depressions known as calderas. That is why today, instead of a towering volcano, the region contains a vast lake. Lake Toba itself sits within the enormous caldera created by that ancient eruption. But before it became the peaceful lake we see today, this place was once the center of one of the most powerful geological explosions in the history of our planet. When we look at geological processes like this, we begin to notice something profound. The events that change Earth's history rarely begin with dramatic explosions. They begin with slow movements. Movements so gradual that no human could notice them within a single lifetime. Tectonic plates drift only centimeters per year. Magma accumulates little by little beneath the surface. Pressure builds over hundreds of thousands of years. And then, in a brief moment on the scale of geological time, all that energy is suddenly released. Interestingly, Carl Gustav Jung once suggested that nature sometimes mirrors similar processes within the human mind. Within our own psychology, hidden forces may slowly accumulate emotions, memories, and unconscious tensions that can exist quietly for many years before eventually surfacing. Jung called these deeper layers the unconscious. Like magma beneath the Earth's crust, the unconscious may hold powerful energies. And sometimes when pressure grows strong enough, those energies also find a way to emerge. So when we look at the story of the Toba supervolcano, we are not only seeing a geological phenomenon, we are also witnessing a powerful symbol of how unseen forces, whether in nature or within the human mind, can slowly accumulate over time before suddenly reshaping the world. The terrifying scale of the eruption, when modern scientists attempt to understand the ancient eruption of Lake Toba, they often begin with a simple approach. They compare it with volcanic eruptions that humans have witnessed in recent history. Those events for us already seem enormous, but when placed beside Toba, they suddenly appear much smaller. Let us begin with an eruption still remembered within modern history. In 1980, Mount Street, Helens erupted after weeks of earthquakes. The explosion collapsed part of the mountain and sent an enormous ash cloud tens of kilometers into the sky. Hundreds of square kilometers of forest were destroyed. Ash spread across several American states. For those who witnessed it, it was one of the most dramatic eruptions of the 20th century. Yet when geologists measured the amount of material expelled by Mount Street Helens, the total was about 1 cubic kilometer, a large number by human standards. But far from the largest eruption in Earth's history, another famous eruption occurred in 1883, when Krakatoa exploded with extraordinary force. The sound of Krakatoa's explosion was reportedly heard thousands of kilometers away. Massive tsunamis swept across nearby coastlines, killing tens of thousands of people. For months afterward, the skies of the world glowed with brilliant red sunsets caused by volcanic ash in the atmosphere. Krakatoa expelled roughly 25 cubic kilometers of material, much larger than Mount Street Helens. Yet Earth's volcanic history still contains events of even greater magnitude. In 1815, Mount Tambora erupted in one of the largest natural disasters ever recorded in human history. The eruption released so much ash and sulfur into the atmosphere that the following year, 1816, became known as the year without a summer. Temperatures dropped, harvests failed, famine spread across parts of the world. Tambora expelled around 160 cubic kilometers of material, an immense eruption by any measure. And yet, even Tambora cannot compare with Toba. When geologists studied ancient ash layers found across large parts of Asia and the Indian Ocean region, they discovered that the eruption of Toba was vastly larger. Modern estimates suggest the eruption expelled roughly 3,000 cubic kilometers of material, 3,000 cubic kilometers, a number almost impossible to imagine. Compared with Krakatoa, Toba was more than 100 times larger. Compared with Mount St. Helens, the difference becomes almost unimaginable. These numbers reveal that Toba was not simply a volcanic eruption. It was a planet-scale geological event. The ash plume may have risen over 30 kilometers into the atmosphere. Pyroclastic flows, scorching clouds of gas and ash, raced across the landscape for hundreds of kilometers. Meanwhile, tiny ash particles were carried by high-altitude winds across vast areas of the planet. Those particles eventually settled across distant lands, forming layers of ash that scientists can still identify today. When we reflect on the scale of this event, a certain feeling naturally arises, a sense of humility before the power of our planet. Today, humanity can build enormous cities. We can send spacecraft into orbit. We have created global networks of technology connecting people across continents. Yet, before geological forces that have shaped Earth for millions of years, we remain small. Jung described the emotional response to such immense natural forces with the word numinous. It is a feeling of awe, a mixture of wonder and reverence in the presence of something greater than ourselves. Towering volcanoes, powerful storms, the endless stars of the night sky. All of these can evoke that same feeling. Perhaps deep in humanity's distant past, events like the eruption of Toba left powerful impressions on the imagination of our species. A distant memory of a time when the sky may have darkened, when ash fell from the heavens, when nature revealed just how quickly the planet could change. Yet the most remarkable part of this story is not only the power of the eruption, it is the fact that humans survived it. Despite the scale of the disaster, despite the possibility that ash dimmed the sky for months or even years, our ancestors endured. Small groups of humans continued moving across ancient landscapes. They kept fires burning through the night, and they continued telling stories that tens of thousands of years later, we are still trying to understand. The big question: did humanity almost go extinct? When modern scientists look back at the consequences of the enormous eruption of Lake Toba, an important question slowly emerges. It is a question that is both scientific and deeply philosophical. Did humanity once stand very close to the edge of disappearance? For several decades, a well-known hypothesis attempted to answer this possibility. The idea is closely associated with the anthropologist Stanley Ambrose. Ambrose proposed that the eruption of Toba may have caused a genetic bottleneck in the history of humanity. In evolutionary biology, a genetic bottleneck occurs when the population of a species suddenly drops to very low numbers for a period of time. Imagine a wide river flowing across an open landscape. If that river is forced through a narrow canyon, only a small portion of the water can pass through that narrow point. Something similar can happen in evolution. When a disaster drastically reduces a population, only a small number of individuals survive. All later generations descend from that small group. As a result, the species' genetic diversity becomes limited. Ambrose suggested that the eruption of Toba, along with the volcanic winter that followed, may have created extremely harsh environmental conditions for early humans. Sunlight decreased, temperatures dropped, food sources throughout ecosystems were disrupted. Under those conditions, many ancient human populations may have disappeared. According to this hypothesis, the global population of Homo sapiens may have fallen to only a few thousand individuals. Some estimates even suggest the number could have been as low as 2,000 people. If this were true, then every human alive today, billions of people across the planet, could be descendants of that very small group of survivors. It is a striking thought. It reminds us that human history may have been extremely fragile. If only a few events had unfolded differently: a longer winter, a slightly harsher climate, the story of humanity might have ended long before the first civilizations appeared. One reason this hypothesis became so compelling is that it seemed to match an observation in genetics. When scientists analyze the DNA of modern humans, they find that human genetic diversity is relatively low compared to many other species. For example, two chimpanzees living in the same forest can sometimes be genetically more different from each other than two humans living on separate continents. This suggests that at some point in the past, the human population may have been drastically reduced. For Ambrose, the eruption of Toba seemed like a perfect candidate. A colossal geological disaster, a global climate disruption, a moment when the environment may have become far more difficult for human survival. Seen from this perspective, the eruption of Toba was not merely a geological event. It could have been an evolutionary turning point, a moment when the fate of humanity depended on the survival of only a few small groups of ancestors. From the perspective of Carl Gustav Jung, ideas like this touch something deep within the human psyche. Jung believed that beneath individual consciousness lies a collective unconscious, a deeper layer of the mind that stores symbolic memories shared by humanity. Powerful shared experiences, natural disasters, wars, or periods of extreme hardship may leave lasting marks within this deeper layer. Perhaps this is why many cultures around the world contain ancient stories about times when humanity nearly disappeared. Legends of great floods, stories of long winters and darkened skies. Myths of the rebirth of humanity after catastrophe. Though these stories differ in detail, they often reflect the same ancient concern: could humanity disappear from the world? And when we consider the Toba catastrophe hypothesis, that question suddenly feels very real. Perhaps at some distant moment in the past, the entire future of our species depended on the survival of only a few small groups that kept their fires burning at night, groups that continued hunting and searching for food, groups that passed survival knowledge to their children. Those people never knew they carried the future of humanity, but because they endured tens of thousands of years later, we are still here. And the question of Toba, whether it truly pushed humanity to the brink of extinction, remains one of the most fascinating mysteries in human history. New archaeological evidence. For many years, the Toba catastrophe hypothesis encouraged scientists to imagine a dramatic scenario. A supervolcano erupts, the sky fills with ash, the climate changes, and the human population collapses to only a few thousand individuals. But science rarely stops with a single hypothesis. As researchers continued studying ancient sediments and archaeological sites, a more complex picture began to emerge. One important clue comes from Lake Malawi. Lake Malawi is especially valuable to scientists because its sediments preserve delicate records of past climates. Over hundreds of thousands of years, layers of material settled slowly at the bottom of the lake. Each layer is like a page in Earth's diary. When researchers drilled into those sediments and examined layers dating to around 74000 years ago, the time of the Toba eruption, they expected to see evidence of a major ecological collapse. If a volcanic winter had lasted for decades, the surrounding ecosystem should have shown dramatic disruption. But what they found was surprising. The sediment layers did not show clear signs of a catastrophic ecological collapse. Plants appeared to have continued growing. The ecosystem may have experienced changes, but not a prolonged environmental disaster. This discovery led scientists to reconsider the severity of Toba's global impact. Another clue appeared far from Lake Malawi, in the Indian subcontinent. At several archaeological sites in India, researchers discovered thin layers of ash from the Toba eruption. These ash layers act like geological timestamps. They mark the moment when volcanic ash reached the region. But what lies above and below those layers tells a fascinating story. Beneath the ash, archaeologists found stone tools made by humans. And remarkably, above the ash they found similar tools as well. This suggests that humans lived in these regions before the eruption and continued living there afterward. If a global catastrophe had nearly wiped out humanity, we might expect a large gap in the archaeological record. Yet the tools tell a different story. Humans endured the event. Perhaps their environment changed temporarily. Perhaps they had to adapt to new conditions. But ancient communities continued making tools, hunting animals, and living their lives. These discoveries suggest that the story of Toba may be more complex than scientists once imagined. The eruption was undoubtedly enormous. It likely influenced climate, but humans may have proven far more resilient than we once believed. From Jung's perspective, this resilience reflects something profound about human nature. Human psychology was shaped not only by individual experiences, but by the long evolutionary journey of our species. Over hundreds of thousands of years, our ancestors faced droughts, migrations, natural disasters, and competition with other species. These challenges shaped not only our bodies, but also our minds. The ability to adapt, the ability to cooperate, the ability to solve problems in difficult situations. These qualities may have helped ancient humans survive events like the eruption of Toba. They may not have understood why the environment changed, but they could observe nature, they could learn from experience, and they could pass knowledge to the next generation. When we look at those stone tools buried above and below the Toba ash layers, we are not just seeing pieces of rock, we are seeing traces of survival. Evidence that humans continued walking across this planet even when the sky may once have been filled with volcanic ash. And this story reminds us that the history of humanity is not only a story of disasters, it is also a story of adaptation and hope. Modern climate models. In earlier years, scientists imagined that the eruption of Toba might have plunged Earth into decades of severe cooling. Ash and sulfur gases in the atmosphere could block sunlight, causing dramatic drops in temperature across the globe. Forests might die, animal populations might collapse, humans might be pushed toward extinction. But as scientific tools improved, researchers began using advanced climate models to simulate ancient environments. These models use powerful supercomputers to recreate how Earth's atmosphere, oceans, and sunlight interact. By inserting estimates of ash and sulfur from the Toba eruption into these models, scientists can observe how the planet's climate might have responded. The results have produced a more nuanced picture. According to several recent studies, the most severe cooling may have lasted only a few years rather than decades. During that period, global temperatures likely dropped enough to influence ecosystems and environments. Rainfall patterns may have shifted. Wind systems may have changed. Some regions may have become colder or drier for a time. But gradually, ash and sulfate particles settled out of the atmosphere. Sunlight returned. Temperatures stabilized. Earth, like a complex living system, began restoring its balance. The oceans absorbed heat. Atmospheric circulation cleared the sky. Ecosystems slowly adjusted. This does not mean the eruption of Toba was insignificant. It remains one of the largest volcanic eruptions in Earth's history. But it may not have created the decades-long global catastrophe once imagined. From Jung's perspective, this balance in nature reflects something similar within the human mind. Jung believed the psyche also possesses a natural tendency towards self-regulation. When people experience major upheavals in life, the mind may first enter a period of turmoil. Emotions surge, thoughts become chaotic. It resembles the turbulence in Earth's atmosphere after a volcanic eruption. But over time, the mind begins reorganizing itself. Experiences are integrated, lessons are learned. A new psychological balance forms. Perhaps something similar happened with Earth after the eruption of Toba. For a short time, the planet experienced climatic disturbance, but gradually, year by year, natural systems restored equilibrium. As the skies cleared and sunlight returned to ancient forests and savannas, life continued its journey. Animals migrated across open landscapes, rivers flowed through ancient valleys, and small groups of humans, our ancestors, kept living, hunting, and telling stories beneath the night sky. From our perspective, tens of thousands of years later, the story of Toba carries a powerful meaning. Nature can produce immense upheavals, yet life has a remarkable capacity to recover. And perhaps it is this delicate balance between disruption and recovery that has allowed Earth to sustain life for millions of years. Another genetic explanation. For many years, the hypothesis that the eruption of Lake Toba caused a major genetic bottleneck in human history attracted a great deal of attention. The idea was compelling. A colossal natural disaster reduces the human population to only a few thousand individuals. And from that small group, all of humanity slowly emerges again. But science always moves forward by re-examining old hypotheses with new data. In recent decades, a new field of research has opened entirely different ways of understanding the human past. This field is genome genetics, the study of the complete human DNA sequence in order to trace the history of evolution. Every cell in our bodies contains a long strand of DNA, like an enormous book recording information about both our biology and our species' history. Within that book, scientists can find traces of events that occurred far in the distant past. When researchers began analyzing genome data from thousands of people around the world, they discovered something surprising. Evidence of a major genetic bottleneck truly does exist in the history of our ancestors. But that event did not occur at the time of the Toba eruption. Instead, many studies suggest that this bottleneck may have happened around 9,000,000 years ago, long before the supervolcano erupted. According to genetic models, during that period, the population of early human ancestors may have dropped to extremely low numbers. Some estimates suggest that only about 1,280 breeding individuals existed across the entire planet. Pause for a moment and imagine that number. Just a little more than 1,000 humans. If they gathered together in a large valley, they might form only a small community. And from that small community, through hundreds of thousands of years of evolution and migration, eventually emerged all the civilizations of the modern world. It is a thought that makes human history feel both fragile and extraordinary. If only a few events in the distant past had unfolded differently, a longer drought, a harsher climatic shift, the story of humanity might have ended long ago. Yet somehow those distant ancestors survived. They continued to have children, continued moving across the vast landscapes of Africa, and gradually formed larger populations. Over hundreds of thousands of years, their numbers grew again, and the genetic diversity of humanity slowly expanded. Eventually, one branch of those ancestors evolved into Homo sapiens, modern humans. According to current scientific understanding, this means that the eruption of Toba may not have been the primary cause of the major genetic bottleneck in human history. Instead, that bottleneck likely occurred much earlier, during a period when Earth's climate experienced dramatic changes. During that time, glacial cycles may have reshaped the environments in which many species, including early human ancestors, lived. Regions that were once fertile may have become dry. Ecosystems shifted, forcing many populations either to adapt or to disappear. Perhaps it was during this difficult period that the population of human ancestors fell to extremely low numbers. But the important thing is this: they survived. From the perspective of Carl Jung, reflecting on such distant stages of human history can lead to profound insights about human nature. Jung believed the human mind is shaped not only by personal experience, but also by the deep evolutionary history of our species. Deep within the human psyche lie symbolic memories formed across hundreds of thousands of years of survival. Memories of harsh natural environments, memories of cooperation within small communities, memories of enduring difficult times. Perhaps the experiences of our ancestors when humanity existed as only a few thousand individuals left subtle marks within the psychology of our species. Perhaps that is why modern humans still feel a deep connection to nature and a quiet awareness of how fragile life can be. Because deep within our DNA and within our minds, echoes remain from a time when humanity was only a small group struggling to survive on a vast planet. And from those fragile beginnings, the long story of humanity slowly continued, leading to the world we inhabit today. Ancient climate crisis. If we travel even farther back in time, not 74000 years, but nearly 9,000,000 years ago, Earth appears as a very different world. Powerful glacial cycles were unfolding. The planet's temperatures shifted in slow rhythms, lasting tens of thousands of years. Massive ice sheets expanded from the poles, and then retreated again like the deep breathing of the Earth itself. During transitional periods between ice ages, the climate could become extremely unpredictable. Regions that were once wet could grow dry. Forests might slowly transform into grasslands. Rivers could change their courses or even disappear. For the organisms living during that time, these changes were not small environmental fluctuations. They were profound challenges to survival. Many scientists today believe that during this period, distant human ancestors experienced a severe climate crisis. This crisis may not have come from a single dramatic event such as a volcanic eruption. Instead, it may have been the result of several factors combined. One of the most important was climate change during glacial transitions. As polar ice sheets expanded, climates in many regions became colder and drier. Landscapes that once supported abundant life could become harsh and difficult environments. At the same time, prolonged droughts may have occurred in many areas. Lakes and rivers gradually dried. Dense forests shrank, replaced by more arid landscapes. And as habitats changed in this way, another consequence began to appear. Habitats became fragmented. Instead of continuous regions of fertile land, many areas turned into small ecological islands, places where water and food still allowed life to survive. Animals and humans alike were forced to gather around these locations. For early human ancestors, this meant that ancient populations may have lived in very small and isolated groups. One group might live near a valley with water, another near a distant lake or river. Between them stretched dry and difficult lands. This separation may have reduced human populations to extremely small numbers. Genetic studies suggest that during this period, the entire population of early human ancestors may have been little more than 1,000 breeding individuals, a number almost unimaginable compared with the billions of humans living today. Yet once again, the remarkable fact is this: they survived. These small groups continued searching for food, crafting stone tools, and passing survival knowledge to the next generation. From Jung's perspective, such periods of hardship may have left deep psychological impressions on humanity. Jung believed that beneath individual consciousness lies a deeper layer called the collective unconscious. Within that deep layer, the experiences of our ancestors, migrations, struggles for survival, harsh climates may be preserved in the form of symbols and primal emotions. Perhaps that is why humans today still possess a special sensitivity toward nature. We sense changes in the weather. We feel unease when environments grow harsh, and we instinctively cooperate during difficult times. These reactions may not arise solely from personal experience. They may be echoes of hundreds of thousands of years of evolutionary history, when our ancestors relied on one another to survive ancient climate crises. Looking back at that distant era, we begin to understand that human history has never been a straight path. It has been a long journey filled with challenges, periods when climates shifted dramatically, moments when populations dropped to dangerously low numbers, times when the future of humanity hung by a thread. Yet through all those trials, humans endured. Small groups slowly grew into larger populations. Communities gradually spread across different regions of Africa, and hundreds of thousands of years later, from those fragile beginnings, Homo sapiens finally emerged, a species with extraordinary adaptability, a species capable of surviving natural upheavals and continuing to tell its story across countless generations. And when we look back at that distant past, we begin to understand something important. Human existence today is not inevitable. It is the result of many moments of survival, moments when our ancestors overcame ancient climate crises and continued walking across this planet. The genetic impact of bottlenecks. When scientists speak about a genetic bottleneck, they are describing one of the most fascinating processes in evolutionary history. Imagine a vast forest with thousands of trees. Each tree carries different characteristics. Some grow taller, some shorter, some resist drought better, others grow more quickly. This diversity allows the forest to adapt to many environmental changes. But imagine that a disaster strikes a wildfire, a long drought, or a dramatic climate shift, and only a few trees survive. The forest that grows afterward will no longer possess the same diversity. Those surviving trees become the source of all future generations. Something similar can occur in evolution among animals and humans. When a species' population falls to extremely low numbers, many genetic variations may disappear. Rare genes that once existed across many individuals may vanish entirely if the individuals carrying them do not survive. As a result, the species' genetic diversity becomes reduced. For the ancestors of Homo sapiens, this may have happened during periods when populations shrank to only a few thousand individuals. When a small population survives for many generations, the genes within that population gradually become more similar. Not only beneficial genes are passed down, sometimes imperfect mutations also spread. In large populations, harmful mutations are often diluted by genetic diversity. But in a small population, if individuals carrying those mutations produce many descendants, those genes may become widespread over time. Scientists therefore recognize that periods of small populations can leave lasting marks in the genome of a species. And interestingly, when researchers analyze modern human DNA, they still find traces of those ancient periods. Compared with many other primates, human genetic diversity is relatively low. Two chimpanzees living in the same forest can sometimes be genetically more different from one another than two humans living on different continents. This suggests that at certain moments in the past, human populations must have passed through narrow evolutionary bottlenecks, moments when the genetic flow of the species was forced through a narrow passage. When populations expanded again afterward, the entire diversity of humanity was rebuilt from the genes that remained. Seen in this way, the DNA within each human being today is like an ancient book. Within it are passages written hundreds of thousands of years ago, traces of times when our ancestors endured profound natural challenges. From Jung's perspective, the idea that humanity's past still exists within us carries deep meaning. Jung believed that not only our bodies, but also our minds carry the imprint of evolutionary history. He called this deep layer the collective unconscious. Within it exist ancient images and emotions, symbolic memories accumulated across generations of humanity. If our DNA carries traces of ancient crises, perhaps our minds carry similar traces as well. Perhaps that is why humans often feel a subtle awareness of the fragility of life. We know that nature can change. We understand that environments are never completely stable, and we instinctively seek safety through cooperation and community. These reactions may not arise solely from personal experience. They may be echoes of hundreds of thousands of years of evolutionary history, times when our ancestors depended on one another to survive harsh environments and shrinking populations. Seen in this way, every human alive today carries a small part of that ancient story. Within each cell of our bodies lies DNA, passed through countless generations, from small groups of people living across the wild landscapes of prehistory, people who survived droughts, people who endured climate change, people who lived through moments when humanity itself nearly vanished. And because they endured, the story of humanity continues. When we look at our DNA today, we are not only seeing biological molecules, We are seeing traces of a journey stretching hundreds of thousands of years. The journey of people who passed through the narrow passages of history and kept life moving forward on this planet. The survival strategies of our ancestors. When we look back at the difficult periods in the distant history of humanity, times when climates changed, habitats became fragmented, and populations dropped to extremely low levels, a natural question arises. What helped our ancestors survive? Why did many species disappear from history, while humans continued to exist and eventually spread across the planet? Today, archaeologists and anthropologists believe the answer lies in a set of remarkable survival strategies that human ancestors developed over hundreds of thousands of years. One of the most important factors was flexible adaptability. Unlike many animals that depend on a very specific environment, the ancestors of Homo sapiens were able to adjust their way of life when conditions changed. When one region became dry, they could move elsewhere. When familiar food sources became scarce, they could search for new ones. This flexibility allowed humans to survive in many different environments, from dry savannas to wind-swept coastlines. Another important survival strategy was the exploitation of coastal resources. While many animals depended mainly on land-based food, ancient humans began exploring the rich resources found along the seashore. Fish, shellfish, and small marine animals provided a reliable source of nutrition. These foods were often less affected by climate fluctuations than large land animals. One famous archaeological site that illustrates this strategy is Pinnacle Point. Here, archaeologists discovered evidence showing that humans were living near the coast and harvesting marine resources very early in history. Inside caves overlooking the ocean, researchers found ancient shellfish remains, stone tools, and traces of fire. These discoveries reveal that our ancestors were not only hunters on land, they also knew how to gather abundant food from the sea. Another essential survival factor was the use of fire. Fire provided light and warmth during cold nights. It also allowed humans to cook food, making nutrients easier for the body to absorb. Fire could also be used to drive away predators and protect the community during the darkness of night. Yet perhaps the most important survival strategy of all was not a tool or a resource. It was social cooperation. Humans are not the strongest or fastest species on Earth, but we possess a unique advantage: the ability to work together. In the small communities of early humans, every individual played a role in the survival of the group. Some hunted animals, some gathered plants, some cared for children and elders. Knowledge and experience were passed down from generation to generation. From the perspective of Jung, this cooperation reflects something deeper than a biological strategy. It also expresses a profound element of the human psyche. Jung believed that humans carry ancient psychological archetypes, symbolic patterns, shaped by the long history of our species. One of the most powerful archetypes is the image of community. A group of people gathered around a fire in the darkness. A community facing the challenges of nature together. A group sharing food and protecting one another. These images appear in myths and stories from cultures across the world. Perhaps because for most of human history, this is exactly how humans lived. In small communities, where survival depended on connection between people. Looking back from today, it is remarkable to realize that these simple survival strategies, adaptability, coastal resources, fire, and cooperation, helped humans endure some of the most difficult periods in the planet's history. The ancient groups who lived in coastal caves, such as those at Pinnacle Point, probably had no idea that they were playing an important role in humanity's future. They were simply doing what humans have always done, trying to survive and caring for their community. And from those small efforts across tens of thousands of years, the story of humanity continued. A story of adaptation, cooperation, and the ability to find hope, even in the most difficult chapters of history. If we pause for a moment and imagine the lives of the ancient people who lived at Pinnacle Point, we can picture a world very different from the modern one. Before them stretched the vast ocean, where waves constantly crashed against rocky cliffs. When the tide retreated, the rocks revealed countless small marine creatures, shellfish, crabs, and other life hidden in tidal pools. For people living during times of climatic instability, these foods were a precious gift from nature. Unlike large animals roaming the savanna which might disappear when the climate changed, coastal foods were often more reliable. Ancient humans could gather them with simple tools, and with fire they could cook these marine foods, turning them into an important source of nutrition. According to many scientists, exploiting marine resources did more than simply help our ancestors survive difficult times. It may also have contributed to the development of the human brain. Marine animals contain fatty acids and nutrients important for brain growth. As humans began eating these foods more frequently, their brains may have received more energy for development. And as the brain developed, other human abilities also expanded. The ability to plan, the ability to cooperate in groups, the ability to communicate experiences through language and storytelling. From Jung's perspective, these abilities became the foundation of modern human psychology. Jung believed humans do not exist only as isolated individuals. We exist as members of communities where knowledge, memory, and symbols are shared. Perhaps it was in small coastal communities like these that the first forms of storytelling and communication slowly emerged. Imagine an evening tens of thousands of years ago. The sun sinks into the ocean. The sky turns shades of orange and violet. Inside a cave overlooking the sea, a group of ancient people gathers around a small fire. The flames flicker against the stone walls. Children listen as elders describe the day's hunt, the powerful waves outside, or distant lands where other groups live. These stories may have been simple, but they created a shared memory within the community. Through stories, knowledge was passed down, experience was shared, and a sense of connection slowly formed between members of the group. This became one of the most important foundations of humanity, the ability to build communities through language and symbols. Jung believed such symbols do not exist only within culture. They also live within the deeper layers of the human mind. Within the collective unconscious, images, like fire caves, oceans, and small communities, appear again and again across many cultures. Perhaps because they reflect crucial moments in human evolutionary history, moments when our ancestors depended on one another to survive, moments when cooperation and shared knowledge became the keys to survival. And when we look back at the survival strategies of our ancestors, harvesting marine food using fire and cooperating socially, we begin to understand something important. Human survival today is not the result of strength or speed. It is the result of intelligence, flexibility, and connection. These qualities helped small groups of people endure the planet's most difficult eras. And from those small communities along ancient coastlines, the human story continued to spread across tens of thousands of years into the vast world we live in today. The migration out of Africa. If we travel back about 60,000 to 7,000 years, Earth enters a very special chapter in human history. After hundreds of thousands of years living primarily in Africa, a turning point began. A small group of humans left the continent and began the longest journey in human history. These people belonged to the species Homo sapiens, carrying within their bodies the full genetic inheritance of their ancestors. We do not know exactly who they were. Perhaps only a few hundred individuals, perhaps a few small family groups. But from the perspective of evolutionary history, their journey changed the future of humanity. The first steps of this migration may have begun in East Africa, where human ancestors had lived for tens of thousands of years. From there, some groups slowly moved along the coastlines of the Arabian Peninsula. They may have followed routes where water and food were relatively reliable. Beaches provided fish and marine animals. River valleys offered fresh water and edible plants. This journey was likely slow. It was not a migration completed within a few years or even a few generations. Instead, it unfolded as a gradual movement across thousands of years. Each generation may have moved only a small distance, perhaps a few dozen kilometers, but across many generations, humans slowly expanded beyond Africa. They entered the Middle East. They moved across South Asia, then spread into Southeast Asia, Europe, and eventually Australia. From a genetic perspective, this event produced a fascinating pattern. Because only a small group left Africa, all modern human populations living outside Africa today descend from that small ancestral group. This created what scientists sometimes call a second genetic bottleneck. If the first bottleneck occurred hundreds of thousands of years earlier, when human populations fell dramatically, the migration out of Africa created another narrowing of genetic diversity. Only a portion of Africa's genetic diversity was carried into the wider world. Yet from that small portion, human populations gradually adapted to many different environments. Some groups adapted to the cold climates of Europe. Others adapted to the tropical forests of Southeast Asia. Still others learned to live in deserts or high mountains. All of these adaptations occurred while humans still shared a common origin. From Jung's perspective, this migration was not only a geographical event, it was also a psychological journey of humanity. Jung believed the human mind contains a powerful archetype, the archetype of the journey. Across many myths and legends around the world, we encounter stories of people leaving their homeland and entering unknown lands. The journey of a hero, the journey of a tribe, the journey of a community seeking a new beginning. Perhaps these stories echo a very deep memory within the human psyche, because in our evolutionary history, our ancestors truly experienced such journeys. They left the familiar landscapes of Africa. They entered unknown territories with different climates, animals, and challenges. Yet these journeys allowed humans to expand their presence across the planet. Those small groups probably had no idea they were participating in one of the most important chapters of human history. For them, it was simply a journey of survival. They searched for water. They searched for food. They searched for places where their children could live. But across thousands of generations, those quiet footsteps slowly drew the map of humanity across the earth. Today, humans live almost everywhere on the planet, from the frozen Arctic to remote islands in the ocean. And all of those stories, cities, civilizations, and cultures trace back to those first steps taken beyond Africa tens of thousands of years ago. A journey that began with a small group of people, yet ultimately transformed the entire history of humanity. Encounters between human species. When groups of Homo sapiens left Africa and spread across new continents, they entered a world that was not entirely empty. Other human species already lived there. For hundreds of thousands of years before modern humans arrived, other human relatives had occupied these regions. They made tools. They hunted animals. They adapted to their environments. One of the most well-known of these human relatives is the Neanderthals. They lived primarily in Europe and Western Asia for hundreds of thousands of years. Their bodies were strong and adapted to cold climates, and their brains were similar in size, sometimes even larger than those of modern humans. In parts of Asia, another group of ancient humans also existed. Scientists discovered them only recently, based on small fossil fragments and genetic evidence. They are known as the Denisovans. Although fossils are rare, genetic analysis shows they were a distinct branch of the human family. When the first groups of Homo sapiens entered these regions, they did not simply encounter these other humans. They interacted with them. Sometimes this interaction involved competition for resources, but genetic evidence reveals something even more remarkable. These human groups sometimes interbred. In the genomes of modern humans living outside Africa, scientists have discovered small segments of DNA inherited from Neanderthals. On average, about 1–2% of the DNA in many people today traces back to Neanderthal ancestors. In some populations in Asia and Oceania, additional DNA segments come from Denisovans. This means that when our ancestors migrated into new lands, they did not remain completely separate from other human species. They met, they interacted, and sometimes they became part of the same genetic story. From an evolutionary perspective, this had fascinating consequences. Some DNA inherited from Neanderthals and Denisovans may have helped humans adapt to new environments. For example, certain genes related to the immune system helping humans fight diseases in unfamiliar environments come from these ancient humans. Among populations living on the Tibetan Plateau, scientists discovered that adaptation to high altitude may be linked to a gene inherited from Denisovans. This shows that interactions between human species were not merely minor details in evolutionary history. They may have helped humans adapt more quickly to new environments across the planet. From Jung's perspective, this story also carries a symbolic meaning. Jung often spoke about the concept of the shadow parts of ourselves we may not fully recognize yet, which remain within us. Seen symbolically, the presence of DNA from ancient human species within us reminds us that human history is not simple or linear. We are not the result of a single, isolated evolutionary path. Instead, we are the product of many intersecting histories. Ancient humans once met across distant landscapes. They may have shared hunting grounds, water sources, or sheltering caves. And in some moments of history, those encounters created descendants who carried the legacy of more than one human lineage. Looking from today's perspective, this realization brings a profound feeling. Within every modern human may exist a small trace of human species that have vanished. A trace of Neanderthals, a trace of Denisovans, humans who once walked this planet, lit fires in the night, and lived their lives beneath ancient skies. Though they disappeared as separate species, a part of them continues quietly within us. This makes the story of humanity even deeper. We are not only the descendants of a single lineage, we are a blending of many evolutionary stories. And when we look into our own DNA, we are not only seeing ourselves, we are seeing traces of many humans who once shared this planet and who contributed a small part to the long story of humanity. The population explosion of humanity. If we look back at most of the history of Homo sapiens, one fact may surprise us. For hundreds of thousands of years, the human population was very small. There were times in the distant past when the entire human species may have consisted of only a few tens of thousands of individuals scattered across the planet. They lived in small groups, communities of hunter-gatherers that moved with the seasons. Their lives were closely tied to the rhythms of nature. They followed migrating herds across the savannas. They searched for fruits, seeds, and edible plants in the forests. They built temporary shelters or stayed in caves when the colder seasons arrived. In communities like these, population growth was very slow. Each group could only support a limited number of children because a constantly mobile lifestyle made it difficult to care for many young children at once. Nature also imposed clear limits. Food sources changed with the seasons. Droughts or colder climates could reduce the number of animals available for hunting. And so for most of human history, our species lived in a fragile balance with the natural world. The population would rise slightly and then fall again when the environment became harsher. But around 1,2,000 years ago, a major turning point began to appear in the human story. In several parts of the world, humans began experimenting with a completely new way of living: agriculture. Instead of simply hunting and gathering what nature provided, humans began to grow crops and raise animals. Seeds were planted in the soil. Crops were tended through many seasons. Certain animals began to be domesticated. This created a profound transformation. When humans could produce food more reliably, they no longer needed to move constantly as they once had. Communities began to settle permanently in fertile regions. From simple houses, the first villages appeared. Over time, as food production increased, populations began to grow faster. Villages developed into small towns, and those towns gradually became the first cities in human history. From these cities, the great civilizations of the ancient world began to emerge. In places such as Mesopotamia, ancient Egypt, the Indus Valley, and early China, humans built irrigation systems, developed writing, and organized increasingly complex societies. Within just a few thousand years, a very short period compared with the long arc of evolution, the human population began growing in ways never seen before. If we look at a graph of human population over time, we see a striking pattern. For hundreds of thousands of years, the line remains almost flat. But after agriculture appears, the curve begins rising sharply, from a few million people to tens of millions, then hundreds of millions. Today, that number has surpassed 8 billion. From the perspective of Carl Gustav Jung, this transformation was not only an economic or technological turning point, it was also a psychological turning point for humanity. For most of our history, humans lived in small communities where everyone knew one another and shared the same stories. But as populations grew and cities appeared, humans began living in societies far larger than anything our ancestors had known. More complex social structures developed. Laws, religions, and shared systems of symbols helped thousands and eventually millions of people live together. Jung believed that myths and symbols played a crucial role in this transformation. They helped create a sense of shared connection between people who had never met each other. If in the distant past human community meant a few dozen people gathered around a fire, then in later civilizations the community could become an entire city. Yet despite the change in scale, the basic psychological needs of humans remained the same. We still seek connection. We still share stories, and we still try to understand our place in the world. When we look at the explosion of the human population, we see that it is not simply a story about numbers. It is the story of a small species that slowly learned how to organize societies, share knowledge, and build complex civilizations. A species that once lived in small groups within nature has now become a force, shaping the entire planet. And that story continues every day in the world we live in today. The genetic legacy of ancient disasters. When scientists began decoding the genome of Homo sapiens, they discovered something both fascinating and thought-provoking. Compared with many other primates, humans have surprisingly low genetic diversity. If we compare the DNA of two people living on opposite sides of the planet, for example, one in Asia and one in the Americas, the genetic difference between them is actually very small. In some cases, two chimpanzees living in the same forest may have greater genetic differences than two humans living on different continents. This led scientists to ask an important question. Why does a species with billions of individuals today have such limited genetic diversity? The answer lies in the distant past of humanity. Throughout our evolutionary history, our ancestors experienced several events known as genetic bottlenecks. These were times when the population dropped to extremely low levels due to major natural events. Such events may have included climate change, prolonged droughts, disease, or major shifts in ecosystems. When the population of a species falls to only a small number of individuals, many genetic variations disappear. The remaining genes become the foundation for future generations. Over time, when the population grows again, the entire species still carries the genetic imprint of that earlier narrow population. For humans, genetic studies suggest that such bottlenecks occurred multiple times in the past. There were periods when our ancestors may have numbered only a few thousand individuals across the entire planet. In those fragile moments, the future of humanity depended on the survival of small communities. They lived scattered across the landscapes of Africa and nearby regions. They hunted animals, gathered plants, and adapted to the changing forces of nature. Those people likely had no idea that they carried within them the entire future of humanity. Yet from them, across tens of thousands of generations, the human story continued to unfold. From Jung's perspective, recognizing that humans carry traces of ancient crises can inspire deep reflection about our psychology. Jung believed humans carry not only biological inheritance from our ancestors, but also psychological inheritance. Deep within the human mind lies what he called the collective unconscious, a layer of shared symbolic memory belonging to all humanity. Memories of difficult times, memories of survival in harsh landscapes, memories of cooperation within small communities. Perhaps that is why modern humans still feel a deep connection to nature. We sense the fragility of the environment. We search for safety within communities. And we remain fascinated by stories of survival through difficult times. Stories of great floods, stories of long winters, stories of the rebirth of the world after catastrophe. These stories may not represent direct memories of specific historical events, but they reflect a deeper truth that throughout our history, humanity has repeatedly stood very close to the edge of disappearance. And each time, somehow, we survived. When we look at our DNA today, we are not only seeing the biological structure of the human body, we are seeing traces of ancient disasters, moments when the human population nearly vanished, but we are also seeing evidence of resilience. Because every person alive today is a descendant of ancestors who survived those difficult periods. They endured droughts, climate change, and natural hardships. They kept the fire burning through the night, shared stories, and raised the next generation. From those small communities, the long story of humanity continued. A story written not only in cities and civilizations, but also in quiet moments of survival deep in the past. Lake Toba today, a remnant of an ancient catastrophe. If one, the day you stand on the shores of Lake Toba, the first thing you may notice is its calmness. The water stretches like a giant mirror reflecting the sky. Green mountains surround the lake covered in tropical forests. A gentle breeze moves across the surface, creating soft ripples. In the middle of the lake lies Samosir Island, resting quietly within the landscape. Small villages dot the shoreline. Fishing boats glide across the water, and the glowing sunsets make this one of the most beautiful places in Indonesia. It is difficult to imagine that this peaceful place was once the center of one of the largest natural disasters in Earth's history. About 74000 years ago, this region was not a tranquil lake. It was the mouth of a massive supervolcano. Deep beneath the Earth's crust, magma had been accumulating for hundreds of thousands of years. Pressure slowly built up like steam inside a sealed vessel. Eventually, that pressure exceeded its limits. A colossal eruption occurred. The amount of material blasted into the atmosphere was so immense that scientists classify the event as VEI-8, the highest level on the volcanic explosivity index. Ash spread thousands of kilometers. Skies darkened across large regions of the planet. Earth's climate changed for a time. Yet after the disaster, nature began its familiar process of recovery. The enormous volcanic chamber collapsed, forming a giant basin. Over time, rainfall and streams slowly filled that basin with water. Gradually, a vast lake formed. That lake is Lake Toba today. From above, we can see the outline of a gigantic caldera, geological evidence of the immense eruption long ago. But for the people who live around the lake today, it is not a symbol of catastrophe. It is part of everyday life. Fishermen cast their nets across the water. Green fields stretch across nearby hillsides. Small homes dot the landscape. Nature in its own way has transformed a place once devastated by fire and ash into a thriving landscape of life. From Jung's perspective, landscapes like this often carry deep symbolic meaning. He believed nature reflects processes within the human psyche. A volcano with immense energy hidden beneath the surface can symbolize powerful forces within the unconscious mind. Sometimes those forces erupt, reshaping the landscape of our lives. Yet after chaos, a new balance gradually forms. Seen in this way, Lake Toba today can be seen as a symbol of transformation. A place that once experienced immense destruction, yet over time became a peaceful landscape. It reminds us of a familiar pattern in nature. Great disturbances may occur, periods of chaos may arrive, but over time, life usually finds a way to restore balance and continue. Standing beside Lake Toba today, it is difficult to imagine that this place once stood at the center of an event that may have changed human history. But that contrast is precisely what makes it so remarkable, because beneath the calm surface of the water lies an ancient geological memory, a memory of the planet's power, a memory of disasters Earth has endured, and a reminder that nature, like human life, always contains both chaos and renewal. Closing reflection. When we look back at the entire journey we explored tonight, perhaps the most remarkable thing is not the power of the supervolcano, nor the immense numbers of geology or evolution. The most remarkable thing is our existence. Tens of thousands of years ago, when the eruption near Lake Toba shook the planet, the ancestors of Homo sapiens were small groups scattered across the landscapes of Africa. They had no cities, no advanced technology, no maps of the world, but they possessed the most important things: adaptability, cooperation, and imagination. They lit fires in the darkness, shared food, and told stories about the world around them. They did not know they were living during a critical moment in evolutionary history. They did not know that their small daily decisions, where they moved, how they found food, how they cared for their children, would shape the future of humanity. Yet from those simple acts, the human story continued. Across tens of thousands of years, humans spread across the planet. They crossed deserts. They traveled through forests. They entered icy lands. They encountered other human species and adapted to new environments. And eventually they built the first civilizations. Today, if we look into our own DNA, we can still see traces of that story written inside every cell. Each person alive today is a descendant of ancestors who survived the most fragile chapters of human history. And now, as this story slowly comes to an end tonight, you might imagine the quiet waters of Lake Toba beneath the moonlight, mountains standing silently around the lake, a gentle breeze moving across the water, and somewhere in the distant past our ancient ancestors sitting beside a fire, telling stories about the world. If you enjoy slow journeys through history like this, consider subscribing to Stories for Sleep so you don't miss future explorations. Each episode is a gentle journey through history, science, and the human mind, told in a way designed to help you relax before sleep. Thank you for listening tonight. And now, let your body relax, close your eyes, and let your mind drift slowly, like the calm waters of Lake Toba. Sleep well,